All right, so this is 8.4 in trig, and what we're going to be moving on to here is we're going to talk about the relationships among the trig functions. So this is going to be we're going to spend a few days on this section. The first thing we're going to talk about is reciprocal functions, which is going to kind of be a review. We're going to talk about the even odd functions and how those relate to negatives, dealing with sine, cosine, tangent, etc. We're going to talk about Pythagorean relationships. We're going to talk about co-function relationships, and then lastly we're going to talk about simplifying expressions and proving identities. So each of these slides will kind of be dedicated to each one of these, and then like I said, we will spend a few days in class working on this. But I want to just go back to a little bit of review here in dealing with sine and cosine. So it says we have this right triangle here where a 3, 4, 5 right triangle, special right triangle. It says that show that the sine of alpha squared plus the cosine of alpha squared is equal to 1. So this is going to be one of the relationships that you notice that we use, but I want to just go through this. So sine of alpha is opposite over a hypotenuse, so that's 3 over 5 squared. The cosine of alpha is 4 over 5, and then we will square that. And what you're going to find here is when we square each one of these, we get 9 over 25 plus 16 over 25 is equal to 25 over 25, which is equal to 1. So that shows how this relationship actually works, and you're going to see that that's one of our identities. So we've already kind of given the overview here, so let's just move on to the next slide here, which is just reviewing our reciprocal functions. Cotangent is being 1 over the tangent of theta. Cosecant is 1 over the sine of theta. And secant is 1 over the cosine of theta. Okay, so that's a quick review of our reciprocal functions. Now let's go on to odd functions and even functions. So the big thing here is understanding a couple things. So what I want you to realize is that all of this still goes back to our quadrants. So it says the sine of negative theta. Well, what we can do is, if sine of theta is up here, then sine of negative theta will be going down here. Well, we've already talked about that if sine is down in this fourth quadrant, that it'll be negative. So the sine of a negative theta is the same thing as just saying negative sine of theta. That's an odd function. When the input value is made negative, the entire thing becomes negative. Okay? With cosecant, it's going to be the same thing. It's going to be negative cosecant of theta. And again, think about that. These are the same thing, just they're reciprocals of each other. So they're going to follow the same properties. And then our tangent, negative theta, will end up being negative tangent as well. Okay? Now, even functions means that when you have a negative input, it still gives you the same result as before. So our cosine of negative theta just becomes positive cosine of theta. Secant of negative theta becomes positive secant of theta. And then in this case, even though it's an even function, we have cotangent of negative theta will be negative cotangent of theta. Okay, so that is the same as your tangent. It still becomes negative. Okay, so that will help us a little bit as we move forward. Again, a lot of this is dependent on which quadrant we're in. You know, the cosine of negative here, we have all students take calculus, so our cosine is still positive there. So that's how it turns out like that. Okay, so moving on, so that is, again, that is going to be our even odd functions and the negative relationships between them. Okay, not a huge thing, but we will spend a little bit of time in that. Okay, and then let's move on to our Pythagorean relationship. So we've already determined this from above. You know, we proved that that's what it would be, is that the sine squared of theta plus the cosine squared of theta is equal to 1. We need to know this. This is very, very, very important. So what we're going to do from here is we're going to generate, and I'm going to show you how we get our other trig relationships. You can remember them. It's easy to remember them. But you can also remember that we can get our other trig relationships off of this formula. So watch how this works. The first way to do it is by dividing everything by sine squared of theta. So I'm going to divide everything by sine squared of theta. And then I'm going to simplify. This one cancels out to be 1. If you look at this, we have cosine over sine. If you recall, we said tangent is equal to sine over cosine. So therefore, cosine over sine would be cotangent. So this will be cotangent, and the squared will still be there. Equals, and then we have 1 over sine squared. Remember, 1 over sine is cosecant, so that's going to be cosecant squared. And that is another relationship of ours. Okay? Now the last one is, and I'll rewrite out the top one again, sine squared of theta plus cosine squared of theta is equal to 1. Now we're going to divide out cosine in this one. So we divide out cosine squared, divide out cosine squared, and divide out cosine squared. So again, here we have sine over cosine. That means we have tangent squared of theta. Cosines will cancel out, so that's plus 1. And then we have 1 over cosine squared is the same as secant squared. Okay, so here is our last Pythagorean relationship. Okay, so these are the 3 things. You can remember all 3 of them, or you can just remember the top one and just be able to derive what you need to from there. Okay? So those are that covers the Pythagorean relationships. This next slide talks about our cofunction relationships. Cofunction means when is sine and cosine the same? And we've talked about this briefly. So we have that the sine of alpha here, alpha's here, is opposite over hypotenuse. It's 8 over 17. So it says then the cosine of 90 minus alpha equals what? Well, again, think about where this angle is. Okay, this is the adjacent side and this is the hypotenuse. So it's still 8 over 17. So the cofunction is when it's the other angle. It's 90 minus that. So if we know what this angle is, we know this angle is going to be 90 minus this angle. For example, if this is 40, then this angle has to be 50. The sine of 40 is equal to the cosine of 50. Okay, so those are what we mean by cofunctions, is figuring out if this is what sine is equal to, I can figure out exactly when the cosine is equal to that or the same as that. Okay, and that's what we mean by cofunction. Real simple, straightforward there. Okay, the last thing, which is the thing we're going to be spending the most time on, is the simplifying expressions and proving identities. So here's what we want to go at, and this is kind of what I was talking about in class, that this can be easy when you're following along, but it's really important for you to try and figure these out and go through and say, okay, how can I really simplify these? So this first one is pretty easy. Sine, typically I'm going to leave it as sine. So the idea of these is when you're trying to simplify, what you want to do is you want to try and get everything in terms of one of our trig functions, okay, because we want to be able to cancel things out. So as of right now, I'm just going to go ahead and leave sine right here. I'm going to change secant to 1 over cosine. So I'm going to leave the sine for right now. If we need to do something with it, we will. So I'm going to leave that. I'm going to change the secant to 1 over cosine of phi. And then I'm going to change the cotangent. Again, remember that tangent is equal to sine over cosine. So I'm going to reverse that, and it's going to be cosine over sine of phi. Because what happens now is you can see our fractions. This sign goes across the top. So what's going to happen here is this sign right here on top will cancel out with this sign on bottom. This cosine on bottom will cancel out with this cosine on top. And we are actually just left with 1. So that's just an example of simplifying. Again, we can come up with thousands, hundreds of thousands of these types of problems that we need to be able to simplify. The key is just being able to understand what different relationships we have between them and using some of our identities when needed. Like, for example, this one right here, this is going to be an interesting identity because it is one of our identities. So if you look at one of the identities that we just covered, we said that 1 plus tangent squared of theta is equal to secant squared of theta. So that's exactly what we're going to write here. Secant squared of 90 minus phi. Okay, because that's an identity. Okay, and that's as simple as that one gets. And sometimes we will use these identities to make these a little bit easier. So let's go on to the next one. Here's where it starts getting a little bit more difficult. So again, I look at what I have, and I know the tangents are going to always be turned into sines over cosines because that's what else I have here. Okay, so let's kind of look at this. We have a cosecant on the outside. So I'm going to turn that into 1 over the sine of phi. On the inside, I'm going to leave the cosine for now. I'm going to change the tangent to sine over cosine. And then I'm going to leave my sine the way it is right now. Okay, again, I just changed a couple things. So now everything's in the right form. So now what I'm going to do is I am actually going to cancel out what I can here. So here you'll see that we have cosine and cosine. One's on top, one's on bottom. So one of these three cosines can get canceled out. So let me rewrite this. Next line. So we have sine of phi, and then here we have cosine squared of phi, and then sine of phi, minus the sine of phi. Okay, all I did was cancel out this cosine with one of these cosines. Now what I'm going to do is I'm going to multiply this through the entire parentheses. This is going to create a sine of phi on the bottom. So it's going to cancel out with this and with this. So the sine being multiplied through looks like sine and sine will cancel out. So we're going to be left with cosine squared of phi minus the sine and sine cancel out, so that'll be 1. Now, looking at this may seem like it is completely simplified, but it's really not. Because if you recall, we have an identity that says sine squared of theta plus cosine squared of theta equals 1. So we can rearrange this, so that way this would be the cosine squared theta minus 1. So we can bring the 1 over here, and we can bring the sine squared over here. So this will actually end up being the negative sine squared of phi. So both of these are still equal to each other. All we're doing is rearranging our identity. When we say we want to simplify, we want to get it in the most simple number of terms possible. Okay? So that means if we have to use an identity to cut it down, then that's what we have to do. Okay? All right, so we are going to cut it off there for right now. I would like to talk about this one in class. That's going to be the first thing that we talk about in class and something that we're going to kind of work on together. Okay, so I will see you then. If there's an Edmodo quiz, then go ahead and take that if that's been assigned. If it hasn't, then obviously you don't have one to take. So I will see you in class.